So topic 14, it's about organic chemistry. When we discussed compounds related to carbon and hydrogen and their derivatives, like mostly hydrocarbon when we discuss them in organic chemistry. So what is the meaning of hydrocarbon? What is the definition of hydrocarbon? If I say define the term hydrocarbon means the compound which contain carbon and hydrogen only. So only two elements in hydrocarbon. There are only two elements. Which are the two elements? One is a carbon and another one is hydrogen. So if we find a compound which contain carbon and hydrogen only, what we call those compounds, we call them as hydrocarbon. Example, if I write C5H10, is it hydrocarbon? Yes or no? Is this hydrocarbon? 5 carbon.
Yes.
So it is a hydrocarbon because it contains 5 carbon and 10 hydrogen. Then if I say C3H8 and O, is this hydrocarbon?
No.
So why it is not an hydrocarbon? Because it contains carbon, it contains hydrogen, and it contains oxygen as well. So that's why it is not a hydrocarbon. So for a compound which contains carbon and hydrogen, we call them as hydrocarbon. So definition of a hydrocarbon is compounds contain carbon and hydrogen only. So we call them as hydrocarbon. Then these hydrocarbons are divided into three classes. As we know, carbon belongs to group 4. So if element belongs to group 4, it can form 4 bonds. So carbon maximum can form 4 bonds. So it depends on the bond between the carbon atoms. So between the carbon atoms in the molecule, if we find between the carbon atoms, if there is a carbon and carbon single bond, like only one bond is there, single bond. So that class of a hydrocarbon, what we call that as alkane, Alkane, alkane. Alkane means between the two carbon atoms there will be a single bond. But what is another possibility? That between the two carbon atoms the compound might contain carbon and carbon double bond. If the compound contain carbon and carbon double bond between the carbon atom, what we call that as alkene. This is a name given to a hydrocarbon which contain carbon and carbon double bond. And if we have a hydrocarbon in which between the two carbon atoms there is a triple bond, so if between the two carbon atoms there is a triple bond, like carbon bonded with another carbon and they have a triple bond between them, what we call this class of hydrocarbon, we call that as alkyne. So there are three classes of hydrocarbon. Maybe between the two carbon atoms they might have a single bond. If between the two carbon atoms, if they have a single bond, that class of a hydrocarbon is alkane. If between the two carbon atoms they have a double bond, that class of a hydrocarbon is alkene. And between the two carbon atoms there's a triple bond, that is alkyne. But what will happen if there is a four bonds between the carbon atoms? So one carbon atom bonded four with another carbon atom. So when two carbon atoms have a four bond, they cannot be a hydrocarbon. Why they cannot be a hydrocarbon? Because carbon maximum can form four bond. So if here between the carbon atom there is a single bond, other case double and triple. But if there are four bonds, now they cannot bond with hydrogen. If they cannot bond with hydrogen, so between the two carbon atoms, if they have four bonds between them, it cannot be a hydrocarbon, as it cannot form a bond with hydrogen. So the three classes of the hydrocarbon is alkane, that between the carbon atom they might have a single bond. It might be alkene, between the two carbon atoms there might be a double bond, and it might be alkyne, between the two carbon atoms there might be a triple bond. So example, if I draw a structure, I draw three carbon atoms and they have a single bond. So which kind of hydrocarbon it will be? Alkane, alkene, or alkyne? If they have a single bond, which class of hydrocarbon it belongs to? Because there are three classes. One, if there is a single bond, we call alkane. If there is a double bond, we call alkene. If there is a triple bond, we call alkyne. So you can see single bond is there between the carbon atoms. So what kind of hydrocarbon is this? This is called alkane, A-N-E. Then how many hydrogen? Because it's a hydrocarbon, so if it contains carbon, it should have hydrogen as well. How many hydrogen the left hand side carbon should have? Because carbon maximum can form four bonds. One of the bond is already formed with the carbon on the right hand side. So how many hydrogen it can adjust? Three of them. So one, two, three. The central carbon, two of the bonds are already formed. So how many hydrogen it can adjust? Because carbon maximum can adjust four bonds. So if two are already formed, how many are left? So two are left, that's why it will have two hydrogen. And on the right hand side carbon, it is having a one bond with another carbon. So how many places are left for the hydrogen? How many hydrogen can be attached? So three hydrogen can, three, because maximum is four. One is already involved. Here one is already involved. So how many it can form? Remaining three will be the hydrogen. So that is how we complete a structure. If we know the carbon, we can find the number of hydrogen by just counting the number of the bonds which a carbon can form. As you can see on the left hand side, the left hand carbon, because it is forming one bond with another, so left three hydrogen. The central carbon forming two bond with another like right and left, so left two hydrogen. The third one on the right hand side, it is forming only one bond, so it is left with three hydrogen. Is it clear, this example, how we complete a structure of a hydrocarbon? Any doubt till this point? I'll give another example, but about this one, is it clear? Okay. Another, if I draw C double bonded with C, then C. Now we have to identify what is a class of this hydrocarbon. How to identify the class of hydrocarbon? If you find single bond throughout the structure, it is alkane. If you find any double bond within the structure, it is alkene. And if you find any triple bond within the structure, it is alkyne. So what is the class of this hydrocarbon? Is it alkane, alkene, or alkyne? What is the class of this hydrocarbon? There is a double bond present here. So if there is a double bond, what we call? We call them as alkene. Alkene. And now we have to complete a structure. How to complete a structure? Carbon maximum can form four bond. So on the left hand side carbon, two are already formed. How many hydrogen it can have? If two are already formed, how many hydrogen this can adjust? So it can adjust only two. So this will have two hydrogen. Next to that, the carbon is having three bonds, 1, 2, and 3. How many it can adjust? So it can adjust only one. Next to that, two bonds are there for this. How many hydrogen this can adjust? Two. The last one, only one bond is there. So how many hydrogen it can adjust? Three. So this is how we can complete a structure by just counting how many carbon-carbon bonds are there, and remaining bonds are occupied by hydrogen, and we call them as a hydrocarbon. So a hydrocarbon means compound which contain carbon and hydrogen. It can be alkane, it can be alkene, it can be alkyne. Alkyne is not there in your syllabus. You don't learn anything about alkyne. Mainly you will learn about alkanes and alkenes. Then the second thing is naming the hydrocarbon. How to name? So how to name a hydrocarbon? It depends on the number of the carbon. Using a number of the carbon, you can name them. If it contains one carbon, you will say it is meth. The name should start with meth, M-E-T-H, meth. If it is containing two carbon, you have to learn this table. It should be eth. If there are three carbon, it will be prop. If there are four carbon, it should be but. If five carbon, it should be pent. Six carbon, it will be hex. Seven carbon, it will be hept. Eight carbon, it will be oct. Nine carbon, it will be non. So till 10, you have to learn their names. One carbon, meth, eth, prop, but, pent. Normally, like it's about 5 to 6. They don't give too many, but it can be. So it's better you learn first 10 of them. Now, how to name a carbon, how to name a hydrocarbon? Like the first example, example 1. How many carbon atoms you see here? How many carbon atoms are there? The number of the carbon atoms. So we see three carbon atoms here, 1, 2, and 3. So for 3, what is the prefix used for 3? Prop. So I will say it is prop. And what kind of hydrocarbon is this? If it is an alkane, if the hydrocarbon is alkane, the name should end at ane. If hydrocarbon is alkene, the name should end at ene. And if hydrocarbon is alkyne, yne, so the name should end at yne. So because this hydrocarbon is an alkane, three carbon atoms, so that's why we say prop. And because it is an alkane, so the name should end at ane due to single bond. So it becomes prop ane. Prop because of three carbon, and ane because of single bond between the carbon atoms. Is it clear? This example 1, that how we name this hydrocarbon. So you have to learn this table. You have to learn this table, that how many carbon atoms, that decide the name of the compound. If it is having 1, it is meth. 2, it will be eth. 3, it will be prop. 4, but. 5, pent. 6, hex, hept, and so on. Now we name the second example. 1, 2, 3, 4. 4 carbon. So if there are 4 carbon, what I should say? if a compound contains four carbon atoms. So if it contains four carbon atoms, what we will say? We will say but, B-U-T, this one. So it will be but because of four carbon atoms. And what is the class of this hydrocarbon? Which class it belongs to? It belongs to alkene. So if it belongs to alkene, the name should end at ene. So it is but because of four carbon, and it is ene because of the double bond. So this example, the example 2 is butene. But because of 1, 2, 3, 4 carbon, and ene because they have a double bond. Is it clear? The second example? Any question or a doubt till this point? So it is important that you learn this table about the number of the carbon atoms, and if there's a single bond, the name should end at ANE. If there's a double bond, ENE, and triple bond, YNE. But YNE, you don't find many questions as it is not there as a part for in your syllabus. So I will draw another structure. First thing you have to identify which compound is this, alkane, alkene or alkyne. Which compound is this? Carbon-carbon single bonds throughout the structure. Is it alkane, alkene, or alkyne? So it is alkane, that's right. So we write this is alkane. We identify the class of a hydrocarbon. Then we have to complete the structure. How to complete a structure? Because hydrocarbon means they contain only two elements. One is carbon, another one is hydrogen. On the left hand side, carbon, how many hydrogen it should have? The left hand side. Yeah, that's good. It will have three hydrogen. That's right. Next to that, how many hydrogen? Two are already bonded. So this will be two. That's right. Next to that, two as well. Then next to that is also two. And the last one on the right hand side will have three. So this is how we completed the structure. We completed the structure. That's great. Now, how to name? For naming, we have to recall that table. If there are five carbon atoms, as you can see, there are five. For five, what is the starting, the prefix we use? Prefix means the starting part of the name. So for five, when you see the five means pent, P-E-N-T. So because five are there, so it is pent. We write pent. And because it is an alkane, so if it's an alkane, the name should end at A-N-E. So it is pent-ane. Pent because of 5 carbon, and ane because they have single bond. So 5 carbon atoms make it pent, and because they have a single bond throughout, that's why single bond between the carbon atoms, so it is ane. Then what is the molecular formula? The molecular formula represents the actual number of atoms. The molecular formula represents the actual number of atoms of each element. How many carbon atoms are there? 1, 2, 3, 4, 5. So I will say 5 carbon. So C5. And how many hydrogen? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So C5H12 is the molecular formula of this compound. Molecular formula represent the actual number of atoms present in the structure or present in a compound. Is it clear, this example? Then another example, what is the class of this hydrocarbon? Alkane, alkene, or alkyne? What is the class? Because there are three classes of hydrocarbon: alkane, alkene, alkyne, depending on the bond. Because there's a double bond, so it means it is alkene, Alkene. If it's alkene, so how to name? First, we have to complete the structure and then we name. How to complete the structure? The left hand carbon, how many hydrogen it will have? Because it's a hydrocarbon, so it will have only hydrogens and carbon atoms, so it will have two. That's good. How many hydrogen the central carbon will have? One, because three are already formed. How many hydrogen the right hand side carbon will have? Three. So we completed the structure. After completing a structure, if I say what is a name, so how to work out the name? You have to see how many carbon atoms, one, two, three carbon atoms. So if there are three carbon atoms, the prefix which we use for three carbon atom is prop. So we should write its name as prop. And because it is an alkene, so the name should end at ene. So it will become prop because of the three carbon and ene because of double bond. So propene. And how to write a molecular formula? Molecular formula means the formula which represent the actual number of atoms. So when we count the carbon atoms, 1, 2, and 3 carbon atoms are there. So we write C3. How many hydrogen? 1, 2, 3, 4, 5, and 6. So C3 and H6 is a molecular formula. Then there is also another formula which is called empirical formula. Empirical formula represent the simplest ratio. The empirical formula represent the simplest ratio between the atoms. So when we work out the simplest ratio, we have 3 carbon atoms and we have 6 hydrogen. If I simplify 3 is to 6, I can simplify as 1 is to 2. So this simplest ratio between the atom is called the empirical formula. So the empirical formula will be C1H2. And normally we don't write 1, so we can write CH2. That's the empirical formula. So molecular formula, what it represent? It represent the actual number of atoms which are present in the structure, where empirical formula represent the simplest ratio between the atoms present in the structure. Is it clear? This example and the name of this hydrocarbon. Then another example, two carbon atoms with a single bond between them. What will be the class of this hydrocarbon? Alkane, alkene, or alkyne? What will be the class of this? So it will be alkane. Then we have to complete the hydrogen. How many hydrogen the left hand side carbon will have? The number of the hydrogen on the left hand side, because one is already formed, so the remaining will be 3. How many hydrogen on the right hand side? That is also 3. So CH3, CH3. Now, what is the name of the compound? The name of the compound, depending on the number of the carbon. So how many carbon did you see here? 2 carbon. If 2 carbon, what is the prefix used for 2 carbon? It is eth. Yeah, that's right. Eth, because of 2 carbon, and because they have a single bond between them, so it will be ane. So eth, because of 2 carbon, and ane, because they have a single bond, so it is actually ethane. When we pronounce altogether, it is ethane. Now, what is the molecular formula? Molecular formula represent the actual number of atoms. So molecular formula represent the actual number of atoms. How many? So how many oxygen, how many carbon atoms are there when we count 1 and 2 carbon atoms? So C2. And how many hydrogen are there? 1, 2, 3, 4, 5, 6. So C2, H6. Is it clear? The molecular formula? That 2 carbon and 6 hydrogen are there, C2H6. Now to write the empirical formula, empirical formula is like a simplest ratio. When we take the simplest ratio from the molecular formula, it becomes empirical formula. So carbon and hydrogen, what is the simplest ratio? There are 2 carbon atoms, there are 6 hydrogen. So what, when I simplify this, divided by 2, so it will come out 1:3. So it means it contains 1 carbon atom and it contains 3 hydrogen in the simplest ratio. So the empirical formula is C1 or CH3. So that's how we work out the empirical formula of the compound. By taking a simplest ratio between the atoms which are present in the structure, we got the empirical formula. Is it clear, this example? The hydrocarbon, ethane. Then another example, ethene. Now what we will do, we will try to draw the structure from the name. So name will be given and now we will try to draw the structure. So if I say I want to draw the structure of pentane. So I want to draw the structure of pentane. Pent, I have to check. Pent means what? Pent means 5. So there are 5 carbon. And ane means what? Ane means they will have a single bond. The bond between the atoms will be single. So pentane will draw 5 carbon, 1, 2, 3, 4, 5. Then we'll make a single bond between them because it's an alkane. So we'll make a single bond. And then we complete the hydrogen. The how many hydrogen? The first one left hand side will have, it will have 3 hydrogen. The central one will have 2 hydrogen. Then this will also have 2 hydrogen. This will have 2 hydrogen. This will have 3 hydrogen. So we completed the structure of pentane. Pent means 5 and ane means there is a single bond between the carbon atoms. Is it clear, this example? That how to draw a structure from the name. Another example, if I say I want to draw the structure of bute 2 ene. So first bute, we have to check what bute stands for. The bute stands for 4 carbon atoms. The 4 carbon atoms refers to bute. So I will draw 4 carbon atoms first. 1, 2, 3, 4. 2 ene means there will be a double bond. But which carbon is having a double bond? The second and the third. Because 2ene means the second carbon is having a double bond. So if I count the carbon either from right or left, it does not make difference. This is my first carbon, this is my second carbon. So the second carbon should have a double bond with the next carbon. So there is a double bond. And then rest all we will make a single bond. Because it is bute 2ene, it means the double bond is there at the second carbon. So first we draw the 4, bute means 4 carbon, that's why we draw 4 carbon, and ene means there's a double bond, but because it is 2 ene, it means the double bond with the second carbon. Now we draw the hydrogen. On the left hand side it will have 3 hydrogen. This will have 1, 2 and 3, so it will have only 1 hydrogen. This will have 1, 2 and 3, so only 1 hydrogen, and this is having 1 bond, so remaining 3 hydrogen. So this is how we completed the structure of bute 2 ene. If it was written butene, if it were written butene only, so what does it mean if the number is not mentioned for a double bond? If any number is not mentioned, it means the double bond is with the first carbon. So first we will draw bute means 4 carbon we will draw, and because there is no number mentioned for a double bond, so it means the double bond is between the first two. And now we complete the structure. Draw the hydrogen. This will have 2 hydrogen. This will have 1 hydrogen. This will have 2 hydrogen. And the last one will have 3 hydrogen atoms. So this is how we complete a structure of butene and bute-2ene. Bute-2ene means the double bond with the second carbon, and butene means the double bond with the first carbon. Is it clear? Any doubt till this point? So remember this table. Here in this table 8 are given normally because they are giving around 8, so that's why 8 are given. So if 1 carbon, it should be meth. If 2 carbons, it will be eth. 3 carbon prop, 4 carbon bute, 5 carbon pent, 6 carbon hex, 7 carbon hept, 8 carbon oct. This is not hex, this is oct, OCT. And if it's an alkane, the name should end at ane. If it's an alkene, the name should end at ene. So from the name, you should be able to draw the structure, and from the structure, you should be able to name a hydrocarbon. So both ways in exam, you can find both ways. Like example, if this structure is given and the question is name this. So how to name? because there's a single bond, so it is alkane. And one carbon means meth. And because it is a single bond all around it, so it is ane. So it is methane. Like we used to say, the methane gas, the natural gas. So that is actually an alkane which contains one carbon and four hydrogen. Sometime you have in the question the name is given, say propene, and you have to draw the structure. So from structure they can ask for name, and from name you should be able to draw the structure. So prop means three carbons, so 1, 2, 3. First we draw the number of the carbon, and then ene is there, means there should be a double bond. So because the position of a double bond is not mentioned, so it is between the first and second carbon, and the other or rest will have single. So this will have two hydrogen, this will have one hydrogen, and this will have three hydrogen. So this is a structure of propene. So using the structure, we should be able to name, and using the name, we should be able to write the structure.